Spent a few minutes this morning reviewing our two-dimensional collisions, but with funny angles. When we see a funny angle, we kind of think to ourselves, we don't like funny angles, so we try to get rid of it. When we see a problem like this, two objects colliding like this, we don't like the angle that we see right here. Okay, so we try to get rid of it. We try to turn it into a simple problem with 90-degree angles, with right angles, because that makes more sense to us. We know how to deal with those. We just wrote a quiz today on 90-degree angles, and I think we did pretty well on it. Okay, so let's try to turn these problems into those 90-degree angle problems. All right, let's say we've got something that looks like this. Okay, we've got a car that has a mass of 2,000 kilograms and a velocity of 20 meters per second, going down this way at an angle of 30 degrees. Let's say we've got another car, car 2, that's going this way. It's going directly to the west. It's got a mass of 2,500 kilograms. And it's got a velocity as well of 20 meters per second. Let's say they stick together. Where are they going to go? What's the velocity? Okay, we're not going to solve this problem entirely. We're just going to change it into one of those more straightforward questions where we have those 90-degree angles. Okay, the first thing we would do is try to predict where it was going to go. Now the reality is we don't know exactly where it's going to go. This is a tough one to predict. Okay, we know that it's going to go down somewhere, right? But is it going to go down to the right, or is it going to go down and to the left? My guess would be that the wreckage would go down and to the left. Having said that, if my guess is wrong, I'm okay with that. Okay, it's okay. Okay, in the end, when I get my answer, I'll see that. I'll see that my guess was wrong. The only reason I draw that third vector in there is to help me visualize it. So if it's not quite right, it's not the end of the world. All right. We like to do x and y components, but remember, we've got a funny angle, and we say to ourselves, I don't like funny angles, so we get rid of it. So off to the side over here somewhere, we redraw vector number 1. It's 30 degrees, it's 20 meters per second, and we recognize that it has both an x and a y component. So now let's change that one vector that's 20 meters per second at 30 degrees into two vectors, an x and a y. We're going to find the x component by saying cosine. Cosine 30 degrees is equal to adjacent, which is my x side, over 20 meters per second. X is 20 cos 30, which is going to give me 17.32. 17.32 meters per second. So how much of that 20 is x component? 17.32. Sine 30 degrees is equal to opposite over hypotenuse. Y ends up being equal to 10. So how much of the 20 meters per second is y component? 10. Now what we've effectively got is a problem with only x's and y's, as opposed to funny angles like 30 degrees. When we break it up into our x and y component, we say m1 v1i plus m2 v2i equals mvf. Okay, the masses we know, 2,000 kilograms, 2,500 kilograms, 4,500 kilograms. We know what v2i is. v2i is neg 20. We're solving for vf. What's v1i? What's v1i? Remember, it's x component. It's not 20 meters per second. It's 17.32 meters per second. Okay, we're changing now this 30 degrees, 20 meters per second into x and y. The x part of it is 17.32. So all we're going to do now is say v1i is 17.32. For the y component, once again, it's going to be m1 v1i plus m2 v2i equals mvf. Okay, we know what this is. We're solving for this. This is 0. because it's all x component. We know what m1 is. Can you tell me what v1i is? It's not 20 meters per second. It's almost 10. It's negative 10 because it's downwards, right? So we sub that in as a negative 10. The problem is just like the rest of them, right? Just like the ones we did on our quiz this morning. As long as we get rid of that funny angle, okay, as long as we change that funny angle into an x and a y instead of 30 degrees, 20 meters per second. All right? We had a couple questions for homework last night. I want to take a look at those now. It's page 491. Any issues, please, with either of those questions on page 491? Either or both. Number 2? Okay. Well, we'll do them both if we need to, okay? All right. Let's take a look at number 1 here first. A 97.0 kilogram hockey center stops momentarily in front of a net. So let's make this object number 1. He's the center. He's 97.0 kilograms. He's not moving. He's checked from the side by a 104 kilogram defenseman skating to the east. So we're going to make that object number 2 traveling at 1.82 meters per second with a mass of 104 kilograms. Now it says the hockey center is checked and bounces. So the hockey center bounces off at 18.5 degrees south of east. Object number 1, after the collision, goes down this way at 18.5 degrees south of east with a velocity of 0.940 meters per second and still, of course, a mass of 97 kilograms. Where do you think object number 2 is going to go? Where do you think the 104 kilogram defenseman is going to go after this collision? The other way, right? It's going to go up and to the right. Okay, you can predict that with your knowledge of conservation of momentum, but you can also predict that intuitively. If you glance off of something and it goes to the right, you're going to go to the left. If it goes down, you're going to go up. Okay, we know that it's going to go up and to the right. His mass is still going to be 104 kilograms, but we're looking for his velocity. We don't know what that's going to be. So, the thing we're going to do first here is get rid of that funny angle. What do we say when we see a funny angle? We don't like funny angles. So let's get rid of that funny angle, 18.5 degrees. There's my x, there's my y. The x component is the adjacent side, so I'm going to say cosine 18.5 degrees is equal to adjacent over the hypotenuse, which is 0.940 meters per second. X here ends up being equal to 0.89142. Notice in this case, I didn't actually redraw that vector. I didn't because I thought I could do it on this diagram without cluttering it up too much. In the end, it doesn't really matter. I don't like to have cluttered things, cluttered diagrams and stuff, but if I can do it without cluttering it up this way, then I'll just save myself the bother of redrawing it. Doesn't really matter. Let's find the y component now. Sine 18.5 degrees is equal to y over 0.940. 0.940 times sine 18.5 is going to give me 0.29827. So we don't like the funny angle, we get rid of it. That's what we just did, is got rid of it. Now the problem is not any different than the problem that you had on the quiz, where we have only 90-degree angles. Let's do our x components now. We're going to say Pi equals Pf, and we get two objects, of course, m1 v1i plus m2 v2i equals m1 v1f plus m2 v2f. m1 v1i is crossed off. Why? Devin, why did I cross off m1 v1i?
Because there's no x component.
Well, there's no x component or y component, right? It's not moving, right? M2, object number 2, has a mass of 104 kilograms. V2i is what? For the x component. Is it 1.82 or is it some kind of component or part of 1.82? All of it's 1.82, right, Logan? All of it is. M1 was 97 kilograms. V1F, V1F. V1F is 0.940 meters per second, right? Janaea? 0.940 meters per second? No? We had to get rid of that funny angle by taking components, right? So now anything that was involved with that funny angle is gone. That 0.940 meters per second we're never going to use again. The x component of 0.940 is what? 0.89142. That's what we're going to use now. It's like we just got rid of this vector entirely. Okay, it's like we scratched it out and then replaced it with this and this. Okay, so anything that was involved over there, we're not going to use that anymore except the mass. The mass we can still use because although we changed it into x and y components, mass is a scalar. So mass doesn't change when we do components because there's no direction associated with it. M2 was 104 kilograms. V2F is something. Let's get that number. Let's do it on our calculator up here to make sure that we can get that. Let's say 104 times 1.82. Let's press equals. That's on the left-hand side. Now let's subtract from that, with brackets here, 97 times 0.89142, end the bracket. It's 102. Now let's divide that by 104. We get 0.98858. Final answer? No. We have to do a y component, right? Now, every once in a while, this might be thrown at you. Okay, every once in a while, you may be given an angle rate here. We're not in this question, okay, but you may be given the angle of the final answer. If you are, you can go ahead and solve it the way that we always solve it. Okay, you do the y component and combine them. But if you're given that angle, which happens from time to time, there's a shortcut. Okay, if you have that angle, and we have the x component of object number 2, then we can find the hypotenuse just by using cosine. We don't have to go through the process of doing the y component and then the Pythagorean theorem and so on. Okay? If in doubt, though, just do it the way we always do it. Okay, pretend the angle's not there. All right, in this case, the angle wasn't there, so we have to do it the way we normally do it. Do the y components. We'll say pi equals pf again. Two objects before and two objects after. These two both just disappear. Can we explain why they both disappear in this case? Object number 1 isn't moving, right? It's not moving x or y. So that's why m1 v1i is going to be 0. Why is m2 v2i going to be 0? It's moving at 1.82 meters per second. It's only moving east, and there's no y component. None of it is going up and down. All of it is going east. M1, again, was 97. V1F. .29827, yes. It's not 0.940, right? That number's gone forever now. We've taken that 0.940 at 18.5 degrees and changed it into an x and a y to get rid of that funny angle. So let's plug in 0.29827 meters per second. Is that right? It's almost right. What is it? It's negative, yeah. Why is it negative? Because it's going down. The x component was positive because it was going to the right, but the y component is negative because it's going down. M2 is 104, and we solve for V2F. Let's go back to the calculator again. We'll say 97 times. By the way, we're taking this over to the left-hand side by adding, right? So I'm just going to make it 97 times positive 0.29827. We get 28.93219. Let's divide that by 104. We get 0.27819. Well, we know what to do now, right? Okay, we all know that we're going to redraw the diagram, vector diagram, and we're going to use the Pythagorean theorem. We've got 0.98 to the right, and we've got 0.27819 upwards. Our resultant velocity, or the velocity of this car, or this hockey player, I should say, is the hypotenuse of that triangle. Do the Pythagorean theorem, and when we do that, it works out to be 1.03. When we find our angle, using the inverse tan of opposite or adjacent 0.27 over 0.98, we're going to get 15.7 degrees. And that angle is going to be north of east, because it's north above east. Here we went east and we went north. We went north after east. Or we went north of east. Is that okay? Who was it that asked me for question 1? It's good? Oh, okay. Okay. Yeah, you'd get, if you forgot the negative there, you'd get mostly the same answer. Right? You'd end up getting 1.03. On this side. Yeah. Yeah. So you had 97 times negative 0.29827 on this side. And then you divide by 104. It should have just given you a negative 0.27819. Okay. If you make no other mistakes, missing that negative is going to still give you 1.03. It's still going to give you 15.7. But it's not going to give you 15.7 north of east. It would have given you 15.7 south of east, which doesn't make any sense, right? Because we know this is going to go north of east. Now, how far north of east, we didn't know until we figured that out, but we know it's going to go up there somewhere. Yeah. Okay. As long as it makes sense now. Number 2. Can I erase that, by the way? Number 2, a 1,200 kilogram car attempting to run a red light strikes a stationary 1,350 kilogram car waiting to make a turn. Let's draw the stationary car first. We'll call that M2. 1350 and 0 meters per second. The 1,200 kilogram car, we don't know which way it's going, so it's kind of difficult to draw that right now. Skid marks show that after the collision, the 1350 kilogram car is going this way. 55.2 degrees east of north. And it's going at a velocity of 8.30 meters per second. Of course, it's still going to have a mass of 1,350 kilograms. The other vehicle, vehicle number 1, is going up this way, 36.8 degrees west of north. Object number 1 has a velocity of 12.8 meters per second, and it has a mass of 1,200 kilograms. Okay, if number 2 goes off to the right and number 1 goes off to the left, then number 1 must have been coming from down here somewhere. Now we've drawn it straight up. We've drawn it straight to the north. We don't really know that it's going straight north. It doesn't tell us that. Okay, it could be slightly off of straight north and still cause number 1 to go one way and number 2 to go the other way. So we're solving for a variable that's a little bit different this time. We almost always solve for VF, V1F or V2F. This time we're solving for V1I. Now, we got 2 funny angles here. And when we see 2 funny angles, we always say, I don't like funny angles. Let's get rid of them. So let's do that now. Here we have 12.8 meters per second. We have 36.8 degrees with an X and a Y. Here we have 8.30 meters per second. We have an angle of 55.2 and an X and a Y. The X component here is which side of that triangle. Is it opposite or is it adjacent? Which one is it? It's opposite. So this time we're going to use the sine function for it. Sine 36.8 degrees is equal to opposite over hypotenuse. What does that equal? 12.8 sine 36.8. 7.6665. 6675. Thank you. Let's do the same thing for the y component, except use cos. What does that one equal? Sorry? Thank you. 10.249 meters per second. All right. So that's our little aside, getting rid of that 36.8 degrees and 12.8. Remember, we're still going to use that mass of 1,200, but we're never again going to use that 12.8 meters per second, and we're never again going to use that 36.8 degrees. We've got new numbers to replace those with now. Okay, let's do this one. While we're at it, let's say sine 55.2 degrees is equal to opposite over hypotenuse. What does x equal over here? 6.798. Thank you. And the y component is cosine 55.2 degrees. What does that equal? 4.761. All right, again, we didn't like that 55.2 degrees. We got rid of it. We changed it into 6.798 and 4.761. We will never again use that 8.3 or that 55.2 degrees, ever. It's done. It's gone. They don't exist anymore. The 1350 we will, because it's a scalar, and it's not affected by doing components. All right, let's start solving the meat of the problem now with our x components and our y components. We've got m1 v1i plus m2 v2i equals m1 v1f plus m2 v2f. Now, you can see the answer right above this. It says it's straight to the north. So when we see the answer, we know that there is no x component of v1i. Okay, but if the answer wasn't there, we wouldn't know that. So if we're told that it's going straight north, we can just not do the x component. There's no need of doing it if we know that it's going straight north. But if we don't know, well, then we've got to do it to see that it ends up being 0. Okay, M1 is 1,200 kilograms. V1I is unknown. Okay, what are they? 6.1? 6.815?
And then the other one's 4.736, or 737.
7 point, what is it?
4.7.
Thank you. Right? M2 V2I is 0 because it's not moving at all, right? It's just sitting there. M1, 1,200 kilograms. V1, F. Left-hand side here, remember, it's not 12.8. That's gone forever. V1F for the x component is not 7.6675, but almost. Negative, because it's going to the left. M2 was 1350. And V2F was 6.815. It's positive because it's to the right. All right, let's calculate this. Let's say 1,200 times negative 7.6675 equals, let's add that to, use some brackets here, 1350 times 6.815. And let's divide that by 1,200. You get negative 6.25 times 10 to the negative 4. A car going 10 to the negative 4 meters per second in the x direction. What is that effectively? Nothing, right? Okay, we're going to write that down. But you're going to see that in the end it's not going to matter. Let's try the y component. M2 V2I disappears again because it's just sitting there. V1F, not 12.8, that's gone forever. Braden, tell me what V1F is, please, for the x component. V1F. What is it? Negative 7 point. Okay. No. 10.249, yeah. Positive. And it's positive, right? Because we're doing it with the y component and it's up. and M2 was 1350. The y component of that, it's not 8.3. We got rid of that. We replaced it with 6.8 and 4.7. Which one is the one we want to use here? The 4.7, right? Because it's the y component. And it's positive as well, because once again, it's up. Let's get our number here. Let's say 1,200 times 10.249. Add that to 1,350 times 4.737. Let's divide that by 1,200. You get 15.578. Now, technically, we should draw a triangle here, do the Pythagorean theorem, and do the inverse tan function to find the angle. But what's my triangle going to look like? Well, V1I is 15.578 up, and (6.25 times 10 to the negative 4 over to the left. When we combine those, what are we going to get? Right? It's going to be to a whole bunch of decimal places. It'll be slightly off of this, but when we round it to 2 decimal places, it's still going to be 16, right? Which way is it going to be if we found the angle? Well, the angle is going to be not 0, but 0.00 something, right? So effectively 0, which means what direction is that car going? It's going straight north. All right? All right, what I'd like you to do here right now, guys, is please take a look at one multiple choice question. Multiple choice 17. Okay, we're looking at this diagram, multiple choice 17. We want to find the magnitude of the momentum of the third piece. See what you can do with that over the next 5 minutes. And please submit that answer as multiple choice number 1.